Have you ever looked up at the night sky and wondered about its secrets? The vastness above us has always inspired awe, curiosity, and a sense of wonder that connects us to the people of the past. That deep blue has fascinated humanity for millennia, drawing poets, artists, and dreamers to try and capture its beauty. But what if I told you that thousands of years ago, a civilization managed to capture that cosmic wonder in a jar? Imagine bottling the very essence of the heavens. They created a color so vibrant and stable it's lasted over 5,000 years, surviving the rise and fall of empires and the shifting sands of time. We're talking about Egyptian blue, the world's first synthetic pigment, a color that changed the course of art and technology forever. This isn't just a story about art, it's about science, innovation, and our quest to understand the universe. It's about the intersection of creativity and chemistry. For most of history, people were limited to colors found in nature: reds from berries, ochres from rocks, black from charcoal. These were the hues that shaped early human expression. But a true, brilliant blue was almost impossible to find. The rare minerals that produced blue were scarce, expensive, and often faded with time. So when we see ancient artifacts with this electric blue, it begs the question, how did they do it? What secrets did they unlock to achieve such brilliance? Imagine walking through a museum and seeing a statue from ancient Egypt, its eyes lined with this vivid blue, a silent witness to the passage of empires gazing back across centuries. That blue isn't just decoration, it's a testament to a profound scientific achievement, a message from the past that still resonates today. The ancient Egyptians weren't just building pyramids, they were performing high-level chemistry, experimenting with minerals and fire to create something entirely new. They manipulated raw materials with heat and precision to create something entirely new, a process that required both skill and imagination. This pigment is a direct link to the minds of ancient scientists and artisans, a bridge between their world and ours. So let's embark on a journey, back to the banks of the Nile where this story begins, in a land of innovation and mystery. We'll explore the science, the art, and the audacity it took to invent a color from scratch, an act of creativity that echoes through time. And then we'll return to the present, where scientists are rediscovering its secrets, using modern technology to unlock ancient knowledge. The story of Egyptian blue is about our drive to explore, create, and leave a mark on the cosmos. A reminder that the quest for beauty and understanding is as old as civilization itself. Picture ancient Egypt around 3000 BCE, a civilization obsessed with permanence, the afterlife, and vibrant color. The landscape was harsh, yet the people filled their world with art, symbolism, and a deep desire to make their mark last for eternity. Their art wasn't just decoration, it was magical, with colors holding deep symbolic meaning. Every hue was chosen with care, believed to have the power to protect, to guide, and to connect the living with the gods. Green meant life and rebirth, red meant chaos or protection, and gold was the flesh of the gods, representing the sun's eternal power and the promise of immortality. But blue was a problem. They needed it to represent the heavens, the endless Nile, and the divine. Yet it was the rarest color to find in nature. Lapis lazuli, a beautiful blue pigment, was rare and expensive, imported from distant lands, reserved for royalty and the most sacred objects. Only the wealthiest could afford its dazzling hue. Azurite, another blue mineral, was unstable and could turn green over time, unacceptable for a culture obsessed with eternity and the unchanging nature of the afterlife. The challenge was clear. They needed a blue that was brilliant, permanent, and abundant, something that could stand the test of time and be used by all. So when nature didn't provide, they invented it. The Egyptians refused to accept limitations, turning to innovation and experimentation. The Egyptians, already masters of glassmaking and metallurgy, turned their skills to the problem of color. Their workshops became laboratories of creativity and discovery. They weren't just artists, they were experimental chemists, blending science and spirituality in their relentless pursuit of the perfect blue. They mixed, heated, and observed, searching for a way to transform common materials, sand, copper, and lime, into something extraordinary, something that would last for millennia. Their quest wasn't just about aesthetics, it was a technological and spiritual imperative, a mission to bridge the earthly and the divine through color. This necessity sparked one of the most important inventions in art and chemistry, the creation of the world's first synthetic pigment. The Egyptians' pursuit of blue was a blend of science, art, and faith, a testament to their ingenuity and their belief in the power of color. They set out to create a color as eternal as their monuments, a blue that would never fade, just like the stories they carved in stone. And in doing so, they changed the history of color forever, leaving a legacy that would inspire artists and scientists for generations. Egyptian blue became a symbol of the divine, the eternal, and the innovative spirit of humanity, a color that still captivates us today. Their solution would echo through the ages, a brilliant blue thread woven through the fabric of human creativity and discovery. Creating Egyptian blue was a remarkable feat of early chemical engineering, showcasing the ingenuity and curiosity of ancient artisans. The recipe was deceptively simple: quartz sand, lime, copper, and a dash of natron as a flux to help everything melt and react. These ingredients were carefully ground together and then heated in a kiln to temperatures between 800 and 900 degrees Celsius, a delicate balance. If the kiln was too cool, nothing happened. If it was too hot, the precious blue color was lost forever. The artisans had to control their kilns with incredible skill, relying on experience and intuition rather than modern instruments. Inside the fiery kiln, a magical transformation occurred. The ingredients reacted to form calcium copper silicate, the mineral responsible for that brilliant, luminous blue. Once cooled, the mixture became a glassy blue slab, which was then laboriously ground into a fine powder by hand. Coarser grains produced a deeper, darker blue, perfect for bold outlines and dramatic effects, while finer grains yielded a lighter, more delicate shade, ideal for subtle details and backgrounds. This process wasn't discovered overnight. It took generations of experimentation, trial and error, and careful observation to perfect. Eventually, the Egyptians mastered this complex chemical process and scaled it up for mass production, supplying artists and craftsmen across the land. Egyptian blue became the world's very first synthetic pigment, a true triumph of ancient technology and human creativity. It stands as a testament to their systematic, innovative approach to solving problems and their enduring legacy in the history of science and art. Once perfected, Egyptian blue was everywhere. It democratized blue, making it accessible for art, temples, tombs, and everyday objects. It painted the skin of gods, celestial ceilings, and empowered magical hieroglyphs. Even Tutankhamun's mask features stripes of Egyptian blue alongside lapis lazuli. The pigment was versatile, used in paint, molded into beads, amulets, and inlays. Its stability meant these objects retained their vibrant hue for millennia. Egyptian blue became a valuable trade commodity, beloved by the Romans, who called it ceruleum. But with the fall of Rome, the secret of its creation vanished for over 1,000 years. The world's first synthetic blue became a lost art. For centuries, Egyptian blue was a beautiful mystery. The recipe was lost after Rome's fall, and the pigment became a historical curiosity. Its rediscovery began in the 19th century, as Egyptology flourished. Scientists marveled at the preserved colors in tombs and brought samples to Europe. Chemists identified the main components, silica, copper, lime, but the exact process remained elusive. The breakthrough came with the analysis of pigment from Pompeii, confirming it was manufactured until the 1st century. Researchers experimented with proportions and heating, reverse engineering the ancient process. By comparing lab samples to ancient ones under a microscope, they looked for the telltale blue crystals. Finally, they succeeded. The lost art was revived in a modern lab. Rediscovering Egyptian blue was like solving a 5,000-year-old puzzle. It revealed the ingenuity of ancient chemists and the power of modern science. The pigment's secrets were brought back to life, and with them, a new chapter began. Recreating Egyptian blue today blends archaeology with materials science. Scientists analyze ancient samples using X-ray diffraction and electron microscopy, revealing the pigment's unique crystal structure. With this blueprint, they mix high-purity quartz, lime, and copper oxide, plus a modern flux. The mixture is heated in a controlled furnace, just like the ancient kilns but with modern precision. By tweaking temperature and timing, they refine the recipe, mapping out the conditions for the most vibrant blue. This process reveals the Egyptians' mastery of chemistry and kiln technology. They weren't just mixing at random, they were conducting controlled reactions on an industrial scale. Modern recreations confirm the genius of their ancient technology. Egyptian blue's story is one of scientific discovery, both ancient and modern. Modern science uncovered a hidden property of Egyptian blue, its powerful near-infrared luminescence. When exposed to certain light, The pigment glows intensely in the infrared, invisible to the naked eye. This is due to its unique crystal structure, making it one of the most efficient infrared emitters known. Archaeologists now use this property to detect traces of the pigment, even when it's invisible or faded. Scanning ancient statues and paintings reveals ghostly images of the original blue decorations. This X-ray vision has led to incredible rediscoveries, like finding Egyptian blue on the Elgin marbles, proving classical art was once vibrant and colorful. The hidden glow of Egyptian blue is rewriting art history. It reveals lost masterpieces and changes our understanding of the ancient world. A pigment from the past is illuminating secrets in the present. The story of Egyptian blue challenges our assumptions about ancient technology. Its creation was no accident, it was systematic research and development. The skills needed to make it were linked to glass, faience, and bronze industries. Ancient artisans understood materials, chemistry, and kiln control. Modern tools like electron microscopy let us see what they created, sparking a dialogue between past and present. Studying Egyptian blue pushes the boundaries of materials science and optics today. The journey to understand it is a lesson in humility and innovation. Ingenuity isn't unique to our time, it's a human constant. The ancient chemists who forged this blue were driven by the same curiosity as scientists today. Why does a 5,000-year-old color matter today? Egyptian blue connects us to our ancestors and inspires new technology. Its infrared glow is used in art conservation and biomedical imaging. Its nanosheet structure is being studied for electronics and telecommunications. Artists and conservators use it to reveal and protect ancient treasures. The story of Egyptian blue is about our drive to capture the sky and make it our own. As we rediscover its secrets, we continue the work of the ancients. We're still reaching for the stars, inspired by a blue that first shone 5,000 years ago.